For this session, we have Miccah and Hon speaking about
user experience in the security context.
Okay, so and if you have any questions, you have to log on Slido, and then you have to put your questions there. They will have 5 last minutes for answering your questions. So yeah, you can get started.
Okay, my fire stopped. Unfortunate. Alrighty. So 7 years ago, an internet-wide outage began. Services like GitHub, Docker, Square, Twilio, the SEC, and more all stopped working. And this was one of the biggest outages in the history of cloud computing. What did they all have in common? Well, they used AWS 3 on USDS1, and there was a little problem. A command was entered incorrectly, and a larger than expected amount of servers went down. So much of the existing internet had outages, and the reason why was a typo. Somewhere else in the world, a developer updates an npm package, adding an npm ignore when there was a git ignore in place. What they don't realize are that the 2 files are not cumulative, and an end file gets leaked. Somewhere else in the world, an infra dev adds a Kubernetes role and uses a wildcard for verbs. They're expecting verbs like API verbs like get, patch, and delete. And what they don't realize is that there are Kubernetes-specific verbs like escalate. Somewhere else in the world, a Linux power user runs Steam, and all of a sudden, their hard drive gets wiped. And somewhere else in the world, an engineer misuses AES GCM for encryption, and now 100 million plus phones are vulnerable. So what do all these have in common? Well, they are humans interacting with computers, from typing a command line argument, or this is also developer experience. This is updating an npm package. This is also user experience, like running Steam. And this is all just usability, people interacting with technology. 4 years ago, I gave my first talk at BSidesSF. I spoke about usability in security products. And in retrospect, that talk focused a little bit too much on visual UIs, and it had that assumption that your security team has the resources to build a UI in the first place. I was working at a larger company back then, and now I'm at an early stage startup. So I think that's provided me with much more realistic views about user experience for security teams where the resources aren't quite as in abundance. So today we're presenting Beyond Code and Clicks UX Insights to Security Software to provide a leaner and more general perspective on how to integrate user experience practices in your security software, with understanding that UX is not just visual, it's processes, it's code, it's everywhere. We are engineers at Truffle Security, an open source company known for TruffleHog, the secret scanning engine.
Hi everyone, I'm Miccah, a backend engineer at Truffle Security. I love the terminal and keyboard-driven UIs.
And I'm Han, I'm also an engineer, and I'm very into the visual design side of things.
So I'm an engineer, so I like definitions, and I thought it'd be good to start with the definition of what usability even is. So there are 3 main parts. This is the ISO definition up here on screen. But 3 main parts are effectiveness, efficiency, and satisfaction. You'll notice that visual design and aesthetics is nowhere in this definition. They certainly affect it, but the main point is it's not just about the UI. So why does usability matter? And I'd like to answer that with an example. There's a command line tool called fdisk. It's used for formatting hard drives. And all you need to know about this is that it's a potentially destructive operation. And even though I live in the terminal, I love using command line tools, this tool terrifies me because there's no feedback. It's a stupid command. It does exactly what you tell it to do. So if you tell it to like format your hard drive and it's in use, it's going to format your hard drive. And yeah, just a typo could wipe my drive entirely. Contrast this to another tool called cfdisk, which is basically an interactive text UI wrapper around fdisk. It does the same thing, it formats your hard drives, but it has an interactive component to it. It's so much easier to use because it shows the current state of the system on the screen. I can choose from like a list of options, so I don't have to remember all of the flags or options for it. And it has confirmation prompts, and it warns you about doing stupid shit, like the device is currently in use, so repartitioning is probably a bad idea. So we also need to talk about human-computer interaction, because we're talking about usability of computer programs. And there's really two main ways that we interact with computers, a keyboard and a mouse. But the user experience can vary widely, though, which means that it really boils down to the application design. And there's three main sort of categories of applications that we put up on this slide. There's CLI applications, which is mostly textual interactions, GUI or graphical interactions, and there's also TUI, which is like still in the terminal, which I love, but it brings more of like the GUI interactive format to the terminal. And I think like the last example with fdisk and cfdisk was interesting because they're both terminal tools, but one is much more usable than the other. And it really boiled down to the design of the program.
So earlier we found out that Miccah lives on the terminal and I do a ton of clicking. So a year ago we built a terminal UI after seeing how non-engineers interact with Trufflehog on the command line. And it had us thinking a lot about human-computer interaction. And watching people use it, for some, it was their first time opening the terminal. And how exactly do you build confidence in what you're doing when writing to what seems like the void? How can we improve the learnability? What about discoverability? At the time, we had just we spent a ton of effort and released a cool new feature to open source, Docker scanning. Back then, Docker scanning. So there was all this cool work, and how exactly do people find out about the cool work we've done? Well, they would have to go to the README or the man page, and no one really reads documentation for fun. So going back to the usability, if that all does not really seem all that efficient. So back to HCI. HCI is a bit of an academic term. There's a lot of really interesting research here about humans and computers. And UX is kind of like the implementation side of HCI, which if you think about it, has a lot of great parallels with security. We have security research and security engineering. In my career, I've worked with some really great designers, and they've imprinted into my brain that your users are human, and it's important to design for people. So when we write code, we can really control how data is interpreted and outputted. But things get way more fuzzy for humans. So let's consider the human experience fully. So as a case study, I think the security community is really cool with all this knowledge sharing. And 2 years ago, I got to attend LocoMocoSec, which is a single track conference in Hawaii. And there I was exposed to a lot of different security topics. And I've heard some really interesting things from Patrick Thomas and Travis Peak. They were talking about this open source project, RepoKid, by Netflix. And they were talking about how it does least privilege permissioning in AWS. So Travis and Patrick shared stories about the makings of RepoKid. So before RepoKid, there was a project called RepoMan. You would go to RepoMan, you would find your project, and the RepoMan would look at your project's AWS roles. And from there, you would click a button, and it would figure out the least privilege roles and apply them. Unfortunately, no one really looked at RepoMan. No one really went to RepoMan. It became another dashboard in the background of a million other dashboards. Later on, Travis also shared that there was a conversation with a security team at another company that did something similar, with the big exception that instead of having your users come to you, we're just going to do it for you. So it terminated the instances if it was not configured correctly. Unfortunately, this became known as Murderbot. So I think we all want to work somewhere with a really solid security culture and organizational buy-in, but I don't know about you, but I'd be really apprehensive about working with a team in charge of Murderbot. So this is where RepoKid ended up. It identified projects with vulnerable permissioning, it fixed them, but if things broke, it provided a button of sorts to give developers an out or an undo and restore. So it was a really clever solution. It fixed the low-hanging fruit, and it also identified what projects need a little bit more security handholding. So usability engineering. I'm going to add this little caveat that I am using the words user experience and usability interchangeably, and a lot of people do. They are actually technically different things, and usability is somewhat of a subset of UX, but that said, usability engineering. So improving the effectiveness, the efficiency, and the satisfaction of interactive systems. It uses theories from computer science and psychology to define problems and try to solve them. So it's somewhat of an entire discipline, and I mentioned earlier that security teams do not have unlimited resources. So enter discount usability engineering. This was coined by Jakob Nielsen in 1989, and it broke down usability engineering into 3 parts. 1 was user testing, having people try out your product or your process. 2 is prototypes, low and high fidelity prototypes that you can test early and often. 3 is heuristic evaluations, how to evaluate projects by inspecting them with usability guidelines in mind. Today, we're going to be talking about a third of this, the heuristic evaluations. We're going to go through the Nielsen heuristics. There are other usability heuristics out there, but I'm partial to these because there's only 10 of them, and they're pretty straightforward. So we're going to go through them kind of quickly, but afterwards, we're going to apply it to a somewhat common security scenario. To start, the first heuristic is the visibility of system status. Let your users know what's going on and in a reasonable amount of time. There are performance implications of this. So slow things make your software or process unresponsive or broken. And when you have a process that takes forever to respond to, it actually kind of degrades trust in your security culture as well.
The second heuristic is the match between the system and the real world. You want to communicate things in ways that people understand and avoid jargon and teaching too many new concepts. So a good example of this is a calculator app because it looks like a real calculator and acts like a real calculator, and you don't have to teach people how to use it.
3 is user control and freedom. So HCI is human-computer interaction, and it was a very deliberate decision to start with the word human. So let people be in control. But as all security professionals know, we all make mistakes. So it's really important to give people an easy way out. We mentioned RepoKit earlier. It's a semi-automatic process that allowed the humans to be in charge at the end of the day.
4th is consistency in standards. So people shouldn't be struggling to understand what you mean, and tech doesn't happen in isolation, so it's good to follow conventions. The examples on here are like the hamburger menu. It's pretty common knowledge. When you click on that, you're going to get a menu. And there's also a man page on there, which is kind of a standard way for command line tools to provide documentation.
Next up is error prevention. So the best designs carefully prevent problems from happening in the first place. This is probably one of the hottest topics in security. We've all heard of security guardrails, secure by default, secure by design. All of that focuses on error prevention.
6 is recognition over recall. You want to minimize a person's memory burden. There's a law called Miller's Law that states that you can only hold roughly 7 things in your working memory at any given time. So people shouldn't need to remember every little thing, and you want to make information visible and easily retrievable.
7, flexibility and ease of use. Novice and pro users exist. Every senior was once a junior. So shortcuts speed up interaction, give people a way to do things faster, but also design them so that they are easy to learn and easy to master. So for example, with code, we have functions because we don't want to write the same thing hundreds of times.
The 8th heuristic is aesthetic and minimalist design. Just don't show irrelevant information if it's not needed. Every additional bit of information can lead to information overload, as we're all familiar with alert fatigue and getting too many alerts.
Number 9 is recognizing, diagnosing, and recovering from errors. So errors are going to happen, and it's really important to help people recover and helping them recover intelligently. Security incidents have blameless postmortems, and going back to the earlier example, after the Amazon US East 1 S3 incident, I believe Amazon added the 5 whys to their postmortem process.
And the 10th and last heuristic is help and documentation. So hopefully your system doesn't need too much additional explanation, but still it's always good to provide as much documentation to help people better understand and use the stuff that you make.
So those are the 10 Nielsen heuristics. There's plenty of written information around them, though I will say they typically focus on visual design. But back at university, I did research with Dr. Shana Daly at the University of Michigan, go Blue. Dr. Daly created 77 heuristics for engineering design and creativity. Think industrial engineering with physical product design. So we were wondering back then, if by having these 77 heuristics, would they improve our products, our processes, and our workflows? And the answer is a resounding yes. There is a whole bunch of scientific literature on how heuristics help engineering design, ideation, and creativity. So hopefully we've started to convince you that usability and user experience is not just visual. And given these heuristics, they are also not a checklist of rules that you have to just go through. But with these 10 usability heuristics in mind, we want you to think that it applies to more than just UIs. To demonstrate this and to help introduce these heuristics a little bit more concretely, we're going to tell another story in the form of a security incident.
So the story we want to tell, which some of you may be familiar with, is a leaked API key. So we get this random email telling us we have an exposed AWS secret. You know, we're panicking, our blood pressure is rising. You know, you have all these questions like, is it real? It is real, you find out. Is it even our key? It was our key. You know, who owns it? What organization in our team owns it? Do I need to start a SEV? You know, who do I include? So, you know, we start a SEV. We decide to rotate it. Is it actually rotated? Who knows? You know, and how do we prevent this from happening again? This is the scenario we want to talk about, and use the heuristics to improve.
Alrighty, so a secret was leaked. So let's look into that process in which we can deal with that with usability guidelines in mind. I put the 10 heuristics to the side, and we can have that as like a little reminder to keep usability in mind as we're going through this. So let's think usability, effectiveness, efficiency, and satisfaction. So let's look at to start, let's look at the first heuristic, the visibility of the system status. We had the Domino's pizza tracker earlier to tell us where a pizza is. So is it in the oven? Is it on the way? What about this report? So if I were to disclose this vulnerability, I probably want to know if the company got it. Security at emails are pretty common nowadays, but they're not the standard. So do I know if I'm sending this email into the void? Who knows? Similarly, how do we know these inboxes are monitored? How do we know? Have you all heard of RFC 9116? This is security.txt. It basically just points out, it enumerates how do you contact a security organization. So it has things like emails, and it's like a whole standard. So consistency and standards, we love that. So it's like a good way to acknowledge that your report's going to be looked at. Similarly, we also have vulnerability disclosure programs. Very different levels of effort for a VDP, but it's kind of just understanding that we can provide back status updates with the visibility of the system status, but maybe we could even take it a bit further. Maybe we can structure a form or something when they disclose a bug to us, like, what was your process of getting this? What's the impact? So that said, with just focusing on a single heuristic, I hope you all are seeing that maybe we can form better security pathways just by thinking about it to the side. So we talked about heuristic number 1, but this also affects things like heuristic number 4, consistency and standards, the method of contact, the structure of the information. We also have heuristic 5, error prevention. We're being way more proactive about letting people contact us rather than us always having to reach out to them. So good. That's good. And also having all this streamlines disclosure as well. So is that not number 7, flexibility and ease of use? If you attended the Secret Life of Secrets talk yesterday, we talked about prefixing secrets and random strings for secrets as a way to identify secrets quickly. So also flexibility and ease of use. So 9 and 10 are just kind of a given, error recovery and help in docs, but that all kind of encompasses how you can think a little bit about usability heuristics with reporting a secret.
The next step of the process that we want to talk about is learning about the secret. So the naive approach is to manually research the secret. If it's an AWS key, going to AWS and finding it in the UI, or searching through the docs to try and write a curl request to verify that it's active, going to various different websites to figure out more information about this secret. And this can be tedious, it can be error prone. It's sort of an ad hoc approach. This is not a skill I think that anyone wants to get good at. And yeah, it's very, very inefficient. So if we consider the heuristics here, the naive approach suffered mainly from efficiency of use, which is heuristic 7. And that's a good place to try to improve the process with something like an automated tool. For example, in this case, TruffleHog, the secret scanning tool, could automatically scan the secret and verify that it's active and gather metadata about it. We can also want to consider the human in the system. So from the human's perspective, what would make this more efficient? And really, if you think about it, having all of the context in one place, all of the information about the secret in one place, would really speed up the efficiency of this part of the process. You know, you wouldn't have to search for all of the right bits of information in a 10-page email thread. You just have it in one easy-to-reach place. And also, considering the human, this is a potentially high-stress or time-sensitive event. To kind of minimize the stress of the event, we can think about some of the heuristics. So heuristic number 4, consistency and standards. Having guidelines on how to approach the situation can really minimize the stress because you have a paved road to follow. Also, aesthetics and minimalist design. As we saw earlier, we only want to show relevant information to not overload the human. And last, help and documentation. Again, you don't want to have to be thinking too much in these high-stress environments. So having help and docs can be really helpful.
Cool. So everything's rotated now. Y'all totally trust me, don't you? Well, no. So is the secret live still? I don't think y'all are just gonna trust me, but in security we always hear the words trust but verify. But how do we verify? So that's kind of this visibility of the system status coming up again. But if we're doing this multiple times, we want to do it quickly. That's also flexibility and ease of use. And across the industry, there's actually a pretty standard process for rotating a secret. And I wanted to point that out because sometimes user experience exists outside of just you. It kind of becomes, this follows heuristic 4, consistency and standards. So it kind of becomes a standard. And most people's, in the world of user experience, there's something known as Jacob's Law, where most people spend their time doing other things. So have your things follow very similar designs and decisions patterns once you understand the why and how. And lastly, for actually rotating a secret, having a known path to rotating a secret. So that's number 9 and 10 again, recognizing, diagnosing, and recovering from errors, as well as help and documentation.
So finally, we get to the retro items. This is the last stage of the process. Let's start with a more heavy-handed action item that you may have heard before, and that's adding the security team as a reviewer to all code changes. We kind of know this is a bad idea, but why is it a bad idea? Let's look at the heuristics. So this affects heuristic number 3, user control and freedom. This is giving all of the control to the security team and not allowing the actual code owners to make changes easily. This also affects efficiency of use, or heuristic 7. There's one team blocking all changes. That's clearly going to slow down efficiency. And this also affects helping users recognize and recover from errors, or heuristic 9. This is by having a separate team handling the security. It's somewhat of an opaque process where the actual engineers aren't empowered to learn about and prevent the issue themselves. So we can ask ourselves, is there a process that improves on these 3 heuristics that improve the usability? And one idea is to use a pre-commit hook to catch secrets. So let's go through the 3 heuristics that we identified and see if they've been improved. So the first one was user control and freedom. Is that improved with a pre-commit hook? And yes, I would say yes. People can disable the pre-commit hook. It is a local check, which can be either good or bad, but this is good for emergencies. For example, if the security team is on vacation or things break, then engineers can still have an out and bypass the check. Okay. Does this improve efficiency of use? Well, yes, it's an automated check, which is much faster than a manual human check. And lastly, does this empower users? Does this let users, does this let users learn about and fix the problem themselves? And yes, it's running on their machine and it tells them directly what the problem is. So we hope that this random bug bounty guy emailing us has helped give you a better idea on how we can apply usability engineering and thinking with the Nielsen heuristics to a security situation and process. And we really want to drive home that this isn't just about the visuals. It does play a part in some parts of it, but it really applies to the whole process.
Thank you all so much for coming to our talk. And if you're walking away today, we hope you have these takeaways.
Usability thinking applies to more than just the UI. As we saw in the last story, thinking about usability for a scenario spanning multiple systems can help shape how we design those systems.
2, design for people and not users. The word users also kind of dehumanizes people. But as we're thinking about user experience, we need to consider how people feel and think when using our software, our tools, and our processes.
Acknowledging human behavior and engineering safeguards. So people are going to interact with technology differently, and occasionally they make mistakes. So setting up guardrails for the best course of action is good.
And lastly, we have the Nielsen heuristics for easy peasy DIY discount usability engineering. Thank you all so much for coming. Feel free to ask us any questions you may have.
Okay, so thank you so much, speakers. And so there are a couple of announcements. So we have a vulnerability management session at 12:15 in Theater 9. The coffee stations are open until 3 p.m. today, so if you want, you can get them. And we have headshots all day. And I'd like to thank speakers again, so if you can give them a round of applause.